Welcome to Info Plus. In 2017, astronomers found an object moving through the solar system that looked strange. A month before making it onto our radars, this strange visitor, whose name is Oumuamua, made a close approach to the Sun. By then, it was already moving quickly away from our solar system and on a journey through the universe. Because it was the first known interstellar object to visit our solar system, its arrival sparked intense interest and wonder. The object's strange acceleration near the Sun even made a scientist at Harvard think it might be an alien spaceship. The behavior of the interstellar visitor can now be explained, according to astronomers. So why did Oumuamua speed up in a way that didn't make sense when it was close to the Sun? Did it really have anything to do with other worlds? Lastly, and most importantly, how will this research help figure out where the celestial object came from? Because it had some remarkable traits, Oumuamua caught the attention of astronomers. First of all, it had an odd shape, taking on the appearance of a long, skinny cigar and being up to 400 meters long. This shape had never been observed before on any other asteroid or comet in the solar system. Second, as it went around the Sun, it was spinning like a bottle on its side, which is another thing that no other asteroids or comets do. Astronomers gave it the name Oumuamua, which is Hawaiian for a messenger from far arriving first, because it was the first known interstellar visitor. It came from the direction of Vega, which is 25 light-years away, and is one of the brightest stars in the night sky. The rules of classical physics said that Oumuamua would move much faster than it did, and gravity alone could not fully explain its behavior. Also, the object didn't seem to have ice or give off gases like a normal comet does. Even the solar energy it experienced couldn't explain its odd acceleration, leading people to think it might be moving because of a force other than gravity. But it was still not known what was causing this force. Researchers started coming up with different explanations for the mystery's beginning. The most intriguing of these was the idea that Oumuamua was an alien spacecraft built to use a light sail to catch the force of the Sun's light. Scientists at Harvard thought it might be a thin disk made by a powerful alien race to travel across the Milky Way. Even though the results of this theory fit the available data, many people found it hard to believe that Oumuamua was connected to an alien society. Other, more logical theories that were easier to understand and comprehend were proposed as a result. Solar warmth causes gases and dust to escape from a comet's surface when it gets within a few astronomical units of the Sun. This process is now known as cometary outgassing. The coma and tail observed around a comet are usually caused by this. An extra source of acceleration is provided by the pressure that gases put on the comet's surface as they escape from the comet. This is like how the flames that come out of a rocket give it a push. But the trouble is that this phenomenon only partly explains the comet acceleration in Oumuamua, and the outgassing it phenomenon was different from what is observed in regular comets. The acceleration of the object was proposed by astronomers in 2020 to be caused by the sublimation of molecular hydrogen. Sublimation is the process by which a solid goes straight from its solid state to its gaseous state, without going through a liquid state. The fact that molecular hydrogen neither gives off nor scatters light, making it hard to find using conventional spectrographic methods, is a complicated factor. This indicates that it would have been impossible to observe the interstellar visitor even if it was emitting molecular hydrogen. When a second study showed that it was extremely unlikely that Oumuamua to be a molecular hydrogen iceberg because it wasn't cold enough for those kinds of icebergs to form. This led to the question of how it could hold hydrogen in such a bad place. Also, if hydrogen was there, how could it be sublimating to cause the observed acceleration? These were some of the questions that researchers were trying hard to answer about Oumuamua. To better understand Oumuamua's strange behavior, astronomers looked back at the data that was already available. They were surprised to find a simple answer that had escaped them until then. The solution lies in the irradiation phenomenon. Water molecules in an object can be split apart by ionizing radiation, which makes molecular hydrogen. It's possible that the same thing is happening with this space object. It is assumed that Oumuamua started its journey as an icy planetesimal in the model proposed by researchers. It was hit by low-temperature cosmic rays while it was traveling through interstellar space. This warmed it up as it passed through the solar system. Experiments have shown that when solar rays heat up ice, it changes from amorphous to crystalline, causing hydrogen gas bubbles to escape. This process could explain how the sublimation of molecular hydrogen from Oumuamua and the observed acceleration happened. According to the researchers' model, Oumuamua's acceleration is due to the release of hydrogen bubbles brought on by the formation of its ice as it came in close contact with the sun. The results show that most of the hydrogen made by handling ice on site stays in the water until it is heated to temperatures between 15 and 140 Kelvin. If the rock on Oumuamua has a low convectivity profile, these temperatures can be reached between 50 and 250 centimeters below the surface. But for higher thermal conductivity, the needed temperatures are reached at about 8 meters, as shown in this picture from the study paper. Even though outgassing is a typical thing for comets, the effects on acceleration are almost nothing for comets that are several miles across. However, due to Oumuamua's small size, molecular outgassing could have provided enough force to result in significant acceleration. So this is one of the best natural theories that explain the first interstellar visitor's behavior. But maybe this isn't the last word. Astrophysicist Avi Loeb, who proposed that Oumuamua was made by aliens, has a different idea about how hot its surface is, and he has written a paper about it. Oumuamua is now far away and traveling at a high speed, making it impossible to get a close look. As of right now, we can only depend on the data we already have. In the future, when we may have the chance to observe other objects showing similar acceleration without a coma or tail, more unusual theories may come up to explain Oumuamua's journey and origin.